This is Mohammed, and today is our third live session of DevOps Zero to Hero. And today is May 17th, 2020. So today I will follow up on what we started last week. So last week we started using Docker containers, and we started from our REST application, and we built one Docker container, and we were able to do the same thing as the normal code, but it was containerized. So today I will follow up on that, and I will try to show you how to optimize your Docker builds or your Docker images. I will show just one technique. There are many techniques there, but I will show one very important technique called multi-stage Docker builds. And then I will also continue to kind of dive deeper in containerization, and I will show some examples of building distributed applications, because generally an application does not consist of only one service or one container, but it will consist on many communicating components or containers that need some scheduling, some networking, and other stuff. So if you have any questions related to the previous session, please feel free to ask it now, or send me a message or email, and I will be happy to answer it. So just also another reminder is that the live session of that we have last week is recorded, and it is available for you on the platform. So if you missed it, feel free to review it and post your questions as well. So all right, so where did we stop last week is after Dockerizing our first application. So we built the shopping cart application. We implemented a REST interface for it, and we were able to communicate with it. And then we started building a Docker container that will allow us to share our code or our application without the need for anybody to worry about the code. And also it allows to deploy it in different architectures and in different places without the requirement of building or understanding or changing the code itself. So here I'm sharing my screen and showing the Docker file that I used in order to build that image. So just a small reminder that for a Docker file, you need to describe where you want to start from, like the base image for your Docker container. So generally, people do not start from an empty thing, but they start from an existing image. There are many existing images for different languages, for different products over there. So if you are using Java, for example, there is an initial Java image that you can start from. And if you are using Go, there is an initial Golang image that you can start from, and then start adding your code and adding the needed structures that you the needed instructions in order to build your code and end up with a running version of your application. So here I'm starting my my Docker file from Golang, which is the official image for Go. I'm creating a simple repository or directory here. Then I'm specifying that this is going to be my work directory. So whatever I will do is going to happen in this directory. Here I'm copying my my dependency management files. Then I'm downloading any needed dependency for my code to run. After that, I'm copying my my source code, which is like copy every file that you have in this particular location to inside my work directory inside the container. So it happens that this Docker file lives in the root of my code. So it will copy all my code in there. Then it is a simple Go build, but with some fancy flags in order to work in any architecture that supports AMD 64 with Linux operating system. There are different flags that you can pass on to support different architectures. For example, if you want to run this code on a Raspberry Pi, you need to modify this, for example, this architecture from 64 to 32 probably. And then this is to specify that the binary that I will use as entry point to my container is this one, which is exactly the binary that I built in the previous step. So I will build the binary, then I will say that this is the thing that I need to run. If anybody tries to run my container, he will start with this binary. So I did that, and I tested basically that my container runs. So here I'm in the same folder where we put the code last week, and this is my Docker file that looks exactly to what I was showing. And I did I did the Docker build, and now I can do the Docker run with the port numbers that I want to map, and using my image. So this is the image that I created, which is the name of my Docker identifier and the name of the image. And here I'm specifying the ports that I need to map. Since my container is opening the port 7778, I need to use that in the right side of the port mapping. And on the left side, I can specify any free port in my machine. So doing this should start my server, and you see here that my server started on the port 7778. But in order to talk to this container, I need to use the one that is mapped to my host. So if I want to do a curl here to my API, just to check if the service is up and running, yes, I see that the call is going through and hitting my container, and I can check also that the container is running there. You see that for this container, it has some specific ID. It is using the image that I built, and it is showing the main command that I have in the Docker file. If you see in the Docker file, the last thing, the entry point is this go bin shopping cart. It will show up here. And also it shows that I'm mapping the port 7778 to my host in the port 8989. Also, it shows you can specify. Yes.
Ala Mohamed.
Yes.
Pour ceux qui utilisent Windows, en fait, la compilation ici de le GoOS doit changer, c'est ça? Et après, l'architecture, en fait, ça dépend du pros aussi, doit changer ou pas?
So if you want this to work, you can even delete these flags because they are optional. They were just for me to optimize the build. If you don't specify the operating system and the architecture, then Docker will pick up the default for your system. So if you are running on Windows, it will automatically pick up the right architecture and the right operating system. So if you are running on a Windows with 64 bytes or 64 bits, then it will pick up that for you. If you are not, if you are using Linux or any other system, you can specify that. You can ignore this part, and it will automatically pick up for you. Like Docker will pick up these values for you.
Okay, merci.
All right. So one important thing about this image. So if Docker has in this CLI, you can check the information about your images. So here I can list all the images that I have in my machine, and just trying to see the information about my shopping cart image. So I can see here that I have this image with the tag called latest. It has an ID. It was built about an hour ago, and its size, which is kind of very interesting, is 900 megabytes, which is huge for a Docker image. Because in the beginning of this class, we said that the advantage of Docker is being lightweight compared to virtual machines, but this image doesn't seem to be very lightweight. It contains lots of stuff that we don't need. So this is why I'm trying to kind of present this feature for optimizing Docker builds. this feature called multi-stage builds. So what is the multi-stage build? So if you go to the documentation of Docker, you will see how they explain the evolution of the work they did in order to come up with this idea. So so the main, in the beginning of Docker, they didn't have this feature. So what people used to do, for example, for our use case here, so they will create a Golang Docker image. They will proceed to the build until they get the binary. So in this step, they will create a new image, completely new Docker file, and they will try to share this file from this Docker image to the other one. So you will end up with two Docker images, one for your build, one for your production. So you start by building your binary, and once you are done, you will try to find the file that you built and copy it over to the new image, which is kind of a very painful operation to do. If you have many Docker containers and many stages in your build, then it is really painful, and it takes lots of time to do that. So they came up with this idea of multi-stage, where you can specify different stages in your Docker file, and from each stage you can do some particular operations, and then take only few files from a stage to the second stage, from the second stage to the third stage, until you reach your final stage, where you build the smallest possible executable or binary that you need to give to your customers or to run in your environment. So let's take a look at one of the multi-stage builds that they are giving in this in the documentation, and we will do almost the same for our example, and we will compare the size of the new generated container image. So in this example, they are using also luckily they are using Golang. So they are running from this version of Golang. They are adding their code, then they do the build. So you see here they are doing their build. It is almost in a very close way. They only don't specify the architecture of the processor that the build will be done for. And after building the binary, they will start from another image. So Alpine is known as a Linux distribution that is pretty small, and many people use it for their workloads. So they will start from that particular image. Then they will copy over. If you see this line, they will copy over the binary that they build from where? From 0, which is the index of the previous stage, which is this one. So we have this, the first 5 lines are one stage, then these 5 lines are the second stage. So if you don't specify any name for a stage, it will be kind of associated with an index. So this one will take the index 0, this one is the index 1, and so on and so forth. So here they are saying that from the first, or the stage number 0, copy the binary that you built, which happens to be in this location, and copy it here in my work directory. After that, my new container will contain only the Alpine image and this binary that will be used as the command to be executed. Yeah, so as I was saying, you can specify names just to make it easier for people to use stages. You can give a name for this stage and a name to this one, and if you have more, you can give them different names. For example, you can have let's say a build stage, like a setup stage, and then a production stage, or staging stage, or test stage. You can have multiple of them. You are not limited in terms of number. And this is an example where they name the stages. So they give this stage the name builder. So this is saying that this will do the build of my code. And then in the second stage, instead of saying from 0, they will use the name that they specified here. So they say from this builder, from the previous stage that is named builder, copy the binary and put it in this location, in the dot location, which happens to be the word here. And then my executable will be dot slash the name of the binary, which is app. Do you guys have any questions related to this process?
Là, on n'est pas encore en train de gagner de l'espace. C'est juste là, tu nous montres comment faire les stages, c'est ça?
Actually, this is one of the most efficient ways to gain in terms of size of the image is to use the multi-stage thing, because when you do this, you end up with this small image. Like the final image will be the last one. So the previous ones are all cached, and then they will be removed from your from your container. So the only image that will last and will be persisted is the last one. So I will apply the same mechanism on our use case, and you will see how much resources or how much we will gain in terms of size of the image. So here they are talking about some specifics, because you can stop in a particular stage. So for example, if you want to only run the builder, you can do that. If you want to proceed to the last one, you can just ignore the build target part. All right, so the main difference between the two Docker files that we have. So you see this Docker file. So it ends with this run, and which will build the binary, and this to specify that we are good. The entry point for this container is in this binary. So the next option, which is using the multi-stage. So after building, so here we are building, then we will start a new stage, which will start from the smallest possible image that you can have. For example, there are some known images like Alpine. There is BusyBox. Also, it is very used in the industry. There is Ubuntu, but it is quite larger than others. And there is one particular image that you can start from, which is called Scratch. Scratch is a reserved name to Docker containers. So this is like the smallest possible that you can get. So it is almost like an empty image where you can put a binary and execute it, for example, and it will be very, very small. It will be really close to the size of the binary that you will have, because this is a very lightweight image that you will start from. So as seen in the previous example, so here I'm specifying the name of my stage to be build. So and I will reuse this name in order to copy my binary. So after building the binary, I will copy it here from build, and I will copy it to my path here to /go/bin/shopping cart, and this will be the entry point of my container. So the final output of this Docker file will be only this. So it will not have the big Golang image that is about 800 megabytes. But it will be very small because it started only from scratch, copied over a small binary, and that's all what it contains. So as you see here, the size is 901, and what I will do here, I will modify the Docker file, and I will copy over this. So in order for this to work, I need the as build here as an identifier. Otherwise, I need to do from 0. So now I will do the build again. I want to use the same image name. So now it is, so you see that sometimes the build is so much faster than previous times, because Docker is using a caching mechanism. So So anything that was built before, either in your machine or somewhere else, it will try to reuse as much as possible. So it will not rebuild everything from the beginning. It will try to compare what exists to the new instructions that you have. If they are the same, it will just use the cache. So now we have a new Docker image, and we can see the new size of this one. So now what happened exactly? So we created a new version of the shopping cart, and you see it took the tag of the latest because it was just created right now, and the size is 8 megabytes. So you see the difference. It's huge, and this makes a lot of difference in terms of starting your container. Like sharing it with others. So imagine that you are sharing 8 megabytes instead of 900 megabytes with other people. Also, if you want to run it in a different environment, like for each instantiation, it will need to do a Docker pull for your image. So this will make you gain lots of time and resources as well. Any questions related to that?
Mohamed, mais ici, ça suppose que tu as l'image build avant, que tu l'as fait au moins une fois pour que ça soit partagé, qu'elle soit dans le cache. C'est ça ou pas?
Yes. So what the system will try to do, it will, for every instruction, it will try to see if it did that before. If it didn't do it, it will do it right away. If it was done before, it will use the cache. And same thing when we do a push. So if I try to push this container to the registry, the registry has an internal deduplication mechanism that will compare the different blocks that you have in the image layers. And if it has any existing layer that exists already in the block storage of the registry, it will just reuse that. It will link it to that image, and it will not duplicate it. You will not have any duplication in the registry side as well.
C'est-à-dire là, pour ton premier push, normalement, c'est 900 mégas, parce que tu as le build avec. Mais pour les push après, puisque tu as le build, tu as 8 mégas à faire.
Exactly, and I can even ignore building this part, pushing this part. So if I do, so I can, for example, if I do, let's say I do Docker tag. So I want to create a new image out of this, right? I will call it Docker 2. All right. I will tag this image as shopping cart 2. So now if I do a Docker push, so it will not push anything related to Golang, that is like the mechanism to build the thing. It will not take care of it because it is not part of my final image at all. So all what it will do, it will push the image that started from scratch, added the binary, and said that this binary is my entry point. So if I do, let's say I do this. So it will only, you see here, it is only pushing the 8 megabytes.
Mais ceci est possible parce que tu as le build déjà avant dans le Docker.
So the build is only saved locally. So what you end up pushing is only what you have in your image. And in my image, I can completely delete this one if I want. Like the build one was only used temporarily. So if you see the Docker file here, so anything that is prior to this one, if I don't specify that I need to save it, it can be deleted. It will not remain in your system. So for now, if I want to delete the image that I have with the 900 megabytes, I can delete it, and this will not affect my my image, because my real image, like I could from the beginning, if I use the multi-build process from the beginning, I wouldn't end up with this image, with this huge image here, because it will be used temporarily. Then it will be discarded from my image. So the layers that were used during the build will somehow remain in my environment. So if I do this, and I do a grep on Golang, because I used Golang, so you will see that I will have this because I used it in the build. So whatever I used, it will remain in my machine. but temporarily nothing is related to my shopping cart image. So my image contains only what I specify in the final build, in the final stage. Does this answer your question, or is it still not clear?
Oui.
All right. So now we have we have an image that is like so much smaller than the other one, and we can run it and see just to test if it is doing the same stuff. And yeah, if we do a curl, you see that it's exactly the same thing, because it is just a matter of the same binary, but it doesn't matter how much other stuff you have in the side that you will not use. For example, if you have Golang inside that machine, you will not be in that container. You will not be using it. So it is just an overhead that you have. So it's better to optimize it and reduce to only the needed things to run your container. For example, for Java, for example, if you want to run a Java application, you will definitely require the JVM in order to do that. So there is no other way to do it. You definitely require the needed components from the JVM. Otherwise, it's not going to be possible for you to build any container or run your application. And this is one of the advantages that I see for Golang compared to Java, for example, is the kind of how much you can reduce the container image. And if you reduce the container image, like you are gaining in terms of time, because the pull and push will take less time. You are gaining in terms of resources that you are using, because running a container with the size of 9 megabytes is so much more performant than a bigger image that will require more resources and more disk to save the image. Also, in terms of security, because you are not putting lots of components and you have less security threats or vulnerabilities in this component, because you basically have the scratch image and your binary. So you are kind of limiting the attack surface, or this is how the security guys call it. So you are really limiting the vulnerability of your image.
C'est-à-dire si je fais en Java, je peux pas réduire autant qu'avec Golang, c'est ça?
It's almost impossible to reach an image that is lower than 100 megabytes with Java. Like the latest that I saw is Docker.
Parce qu'en fait, dans la dernière image, tu dois toujours emporter la JVM. Tu peux pas la mettre en haut et comme on l'a fait là.
No, you cannot. No, you cannot, because the JVM itself is required to run the code.
Ah oui, tu as besoin pour l'exécuter, c'est vrai, tu as raison.
So you definitely need the JVM, and there is a kind of there are some optimization being done, but like last year I tried it, and like the smallest version that I reached was about 200 megabytes. I couldn't go lower than that, and this is really kind of penalizing for me, because trying to have a container with 200 megabytes, and if you want to run it in many machines, you will need to consume a lot of bandwidth in order to download these images and transport them from one place to another. So it's like this is a big differentiator for languages like Go and Rust as well. It's pretty small in terms of footprint.
En fait, pour Go, on a besoin juste au début pour compiler le Golang, pour compiler, mais plus tard pour l'exécuter, on n'a plus besoin. C'est pourquoi on peut réduire autant. Tandis que pour Java, on a besoin de Java pour compiler, la JDK pour compiler, après on a besoin de la JVM pour exécuter. Exactly. C'est pourquoi la dernière image, tu as besoin toujours de la JVM, c'est ça?
Yep, correct. Yeah, because in the Java world, you cannot live without the JVM for your code. But since Go compiles to a binary, you can have only that binary. It's something that you can execute in any environment without. So it comes with all the dependency in this same binary. So you don't depend on anything else. Any other questions? Let me check the the chat just to see if anyone has a question. All right, no questions so far. All right. Okay, so I will move on to the next part, which is basically like the meaty part, which runs multi-container or multi-pods for an application. So generally, distributed applications are not one component. So in an application, you can end up with many components running together. Like you can have a front end, you can have a database, you can have any kind of services or distributed services to deploy. And the suggested way to do it is to have every functional component that has a particular functionality to be deployed in its own container. And probably in large organizations, like each component is managed by one team, so they manage the development part of that component, and they deploy it in a container. They manage everything for that small component or functional component. And with that, you can you can have basically a decoupling between the different velocity of your teams, and each team can have its own life cycle management or release management for their component. For example, you can have, if you have a stable component that is not going under a lots of changes, you can have a release each couple of months or 6 months or a year or so. But a new component that you just got started, you will be making lots of changes and using containers and splitting that component and giving it to a particular team. They can do daily releases or like mini releases per day if they want. So the idea is to split your application into distributed, what they call microservices, and each microservice generally is represented by one container that you can deploy independently of the others. The main characteristic of that the container or this microservice should be self-contained and should have some really clear APIs, like it knows what to accept and it knows what to give back. So you know what is the input and the output of this microservice. Like generally also if you end up with running these different containers, it is not practical to go like I did here, just to go run each container separately and make the connection manually. So there are some tools that allow the specification or the description of applications that are composed of different containers. And in this section, we will be looking at like 2 of them, and one of them is kind of the de facto or the most used orchestrator of containers that we know of right now. All right, so yeah, so here so in order to do that, let me just change the theme here. So in order to illustrate this this part, I kind of created a small use case, which is described with this small image here, where I have a front-end application. It is written in React, and it is just showing a list of products, and this list of products is coming from another component. It is written in Go, which is very close to what we did in the last session, but it only returns a list of products with their ratings, and it is getting the ratings from our third component, which for a particular product, it will return back some ratings. So this example, I want you just to take it as an example for illustration. It is not in any way a complete or feature flag like application. So you will see that this rating component, for example, is generating the ratings randomly. So if you give it any input, it will just return the output with some ratings. The products is generating some static list of products, and this guy, the front end, is just showing the list of products returned by this one. So I shared the code in GitHub. So if you are interested, I can go really quick and show what every component is doing. Yeah, so this is the shopping cart. We already did that. All right, so let's start by the rating component. It is very close to what we did with Go. It has a main functionality that starts the server, and the main feature of that is written in this API server. So if you look here, so so I have a handler here for V1 rating. So whenever I get a call on this endpoint, I will just generate a random value, and I will return a JSON object that has a specific description, which is a rating. I can go to show the format of this rating, but this is you don't really need to see all of that, but just for clarification, if you are interested. So the rating has an ID, a number of stars, and the color of these stars. So it can, for example, for potato, it will return 4 stars, and the color is blue or green or red, something like that. The second one is the products, which will be, if you still remember, so I showed this component, the ratings. Now I will show this products that will consume the ratings from this one and return them back to the front end. Same structure. And it has a handler as well. So for this handler, so anything that comes on /v1/products, it will generate this. So basically, it will create 3 products: potato, banana, pepper, with some description. Also, it will for each one of them, it will call the method getRatings, which is basically calling the other service and getting the ratings for that particular item. So this is like very straightforward. Doesn't have any complications, and it's also very random. The React products is a simple React application. Like it is doing a get on a particular address. I will be changing that in a second to the right address, but it is doing a get on this thing with the jump here, the product context. So it will call that with a /products, which is the endpoint of the products that we have. So this like it will just make a get and simply show whatever return from the product environment or the product container, and it will show it in just some cards. So as I said, you don't really need to understand like what is being written in the code. I have the Docker images, and we will use these Docker images independently of the content of this thing. But you need to understand that this is a front end, this is a backend Go that uses a rating service that is written in Go as well. Any questions here? All right, so here I specify the ports that will be used, and I will show the Docker files of these images just for the clarification. Okay, so now instead of as I said, there is a first option, which is just to go and start creating the containers one by one and making sure that the communication is happening between them. But this is not really what happens in real world environment. You don't do that. It is really rare to use Docker run by itself, but generally you use some other tool to do it. So in this example, I will start by using Docker Compose. So Docker Compose is a tool that allows to describe a distributed application, and it will describe how the different components of this application communicate with each other. Like, for example, what each container is exposing. If you need to specify any persistent storage for your components, you can do it there. If you need to specify any parameters that you need for your application, you can specify it there. So in our use case, it is very straightforward. So we have 3 containers. we will be only exposing their ports and running them by default. We will not do any particular fancy configuration of that. So this is how a compose file looks like. Basically, you start with the version of your Docker Compose version, and you start describing your services. What are the different services that you want to have? And if you look at the image here, you can deduce that you will need 3 services: one for the ratings, one for the products, and one for the front end. Here we go. So we have an image for our front end. I call it just web. And we have the product service, which uses the image for Go products. And it is using some specific tag that I'm referring to here. And you have the ratings, which is the third service. And it is using this image and using this port. If you find this somehow confusing, please just chime in and ask me any question, and I can try to answer your questions. Also, if you have a prior experience with Docker Compose, you might know already that it can get really more complicated than that, because if you start managing persistent storage, it will get complicated, and the Docker Compose file will be bigger than this one. All right, so if there are no questions, I can just go here. So I have I already shared the files here. So let me see. All right, so okay, so I have this repo. I shared the link in the platform. It has 2 folders, one for Docker Compose and one for Kubernetes that we will use later. So the Docker Compose, it has the file exactly containing this content. So I have that locally in my machine. All right. Compose. All right, so here I have that file. Let me show you the content of the file. It's exactly what you saw in the platform. So now, if you already have Docker Compose installed in your machine, then you will be able to do the same thing with this same file. You don't really need to do any changes. You don't need to have the code. You don't need to have anything. The only thing that you need to have is Docker installed and Docker Compose installed in your machine. Then in the same folder, in the same location where you have this Docker Compose file, you can do Docker Compose app. So let's just make sure that we are not having, so I don't have any container running right now. So I will do a Docker Compose app, and Docker here will take care of the rest. So basically, it started the web application, it started the products, it started the rating, and here you see that my container started, and you see the log of each one of them separately. So you have the products and the ratings API, and I can see now how many containers I have. So I have 3 containers, and I need to see only the React application, which is my front end, and it is exposed on this port. So here, so this port was specified in the Docker Compose. If you look at the Docker Compose content, like the ports exposed, I think I explained that last time, but it is generally confusing how to make this mapping. So the mapping should be like the right part of the mapping is the port exposed by the container itself, and the left side of the port is basically any free port in your machine. So here it happens just I specified 8989. I could specify any free port that I want to use. So if I go here and like I have also the link here. So if you any questions,
Mohamed, ici tu supposes que tu as les 3 applications, tu as déjà les Dockerfiles, tu as déjà copié tu as les applications avec leur Dockerfile.
Yes, yes. So I have the applications. I have built the file. So I was showing the content of these repos, and if you look at every one of them, you will see that I have a Docker file. So for the Go for the Go applications, you will see I use it the same multi-stage build. I will start from scratch, and then I will copy the binary that I built. Same for the products here. If you see, it's almost the same. I'm only changing the binary or the name of the binary that I'm building. It's almost exactly the same way to do it. For the React though, it is a little bit different because it is a web application. So I'm doing some specific React build. And after the build, I will start from an Nginx image, which can run as a web server, or you can use Apache if you want. But here I used Nginx because it is always smaller than Apache. And I'm copying the build, which is the result of building my web application, and that's it. Like I'm starting on port 80.
Ok. Et là, lorsque tu lances le compose, tu n'as pas besoin vraiment de... Le compose, c'est lui qui va créer les images. C'est pas à toi de les créer.
So compose supposes that these images exist. So
donc tu l'as déjà créé avant, c'est ça?
Yeah, yes. And I created them using the same mechanism, which is Docker build with giving the Docker file and the name. And I used the names that I have here, like this is the ID and this is the name of the
tu l'as fait avant, tu l'as pas fait maintenant, tu l'as fait avant.
No, I did it before, yeah, because I suppose that this is something that we know, but I will be modifying that in the future, and I will go through the same process in order to modify or to make any change.
Ah, c'est pourquoi, oui, je vois que tu as utilisé des images ici, et ça c'est le tag compose à chaque fois, c'est ça?
Yes.
C'est le nom de l'image et avec le tag, d'accord.
Yeah, yes. So if you go to Docker Hub, for example, let me jump to Docker Hub, and if you go to my account and see here, you will see that I have React products, for example, and you can see the different tags that I have, because I was preparing for this course, so I went through the build for different versions. So you will see that I have the compose tag for this particular image that I shared. I created it 30 days ago.
Tu as fait tes homework, nous on l'a pas fait.
Yeah, you see. Yeah, same thing for Go ratings. You can see that I have the compose 13 days ago. I pushed it, and whenever I create a new version, I just push it. So they already exist. So when I do the Docker compose, it will try to see if these images exist. If it doesn't find the images, it will fail. So it will not try to build them. There are some configurations that you can do in order to mix the build and the run together. So you can have in your Docker compose first part to build your images and run them on the fly.
Bonjour Mohamed. Juste pour les bonnes pratiques, est-ce que c'est pas mieux de builder l'image dans le fichier Docker Compose automatiquement? Parce que dans tous les cas.
So this is a very good question, but generally what is suggested is to separate these different steps, because in large projects you really end up having a build stage. So you have a build stage, a test stage, then a deployment stage. So if you have that, then the build should be separate from the deployment. So you don't want to run Docker Compose while you are building your images. So you need to build them, then push them somewhere, and then probably even it's a different team that will do the deployment. So then just share the Docker Compose, and people will just use the compose to run it. So it's encouraged to have these two stages separate.
Avec la commande Docker Compose Build App, on peut en même temps builder et démarrer le service.
I agree with you. We can definitely have both of them running together. So you can do the build and the run at the same time. But what is generally suggested is to separate these two steps. Why should we separate these two steps? Because first, these are two different stages in your pipeline in general. So the first stage is to build your stuff. The last stage is to run it. So it is always better to separate these two things. So you have your build running by itself, and also your deployment is independent of the build. But you can kind of make a link between them. Like in order to make the deployment, you need to go through the build, to run some tests, to validate your results, and then do the final deployment. And this is why people generally try to split these two things. And if you are familiar also with Kubernetes, it is also the same paradigm. You need to build your containers out of Kubernetes. Then you need to make the deployment using Kubernetes. And you.
Exactement. Dans les Kubernetes, là, on sépare dans les phases de déploiement et les phases de mise en service, l'exécution. C'est juste pour les cas de Docker Compose, parce que avec Docker Compose, dans les cas de Swarm, on peut nous builder l'image et démarrer nos services en même temps, juste avec Docker Compose Build App. C'est facile.
Yeah, technically you can do that. Technically, you can do the build and the run. For you, it facilitates the thing because you will do only one command. But for large teams and for large projects, it is you are mixing two stages together, and it is not suggested to do that. So you need to separate that. Like if you are doing some local development, then it's always fine to do it. To do a build and run, because it will make things faster for you locally. But in a pipeline, in a real pipeline, you should not do that.
Yeah, donc dans les bonnes pratiques, toujours on sépare la phase de build avec par rapport à la phase de l'exécution et
Yeah, and this is one of the best practices, especially in large projects. You should not do that at the same time.
Okay, thank you very much.
And generally, like you can even have different teams. So one team will be writing the code and doing the first build to test, and you will have another team that is responsible of the deployment. So you should not mix both things together.
Surtout que tu peux avoir des images sur lesquelles tu n'as pas de contrôle, c'est-à-dire des images qui sont produites par d'autres équipes ou tu importes juste pour les utiliser. Donc, c'est pas à toi de les créer. Donc, c'est pas...
Yeah, but this is as you said, Ahmed, it's useful when you are doing local tests because it makes things faster for you. But in big projects and if you are collaborating with others, it is not recommended at all. All right, so it seems like our application is up and running, and it is time to go see how it looks like. So if you follow the same steps, you should have the same result here. So it is a bunch of cards, like different components. These are like different React components. Each component is showing the name and description and a rating. If you refresh, you will see that that the rating will change, which doesn't make sense in general, but it's just showing that that I'm really doing that in real time. So it's not so like the application is calling the products are calling the ratings, and this is being generated automatically. Any questions so far? Did anybody, by the way, did anybody succeed to run this locally? Or like just to see if people are preparing their homework. All right. Any more questions related to Docker Compose? So I don't want to lose so much time on Docker Compose because it is not like the best way to do the deployment of your applications. Like the fight around deploying distributed applications is almost resolved, and the clear winner is Kubernetes. And like many of the other competitors start to align with Kubernetes and implement Kubernetes in their systems. Even Docker themselves, they are kind of trying to integrate with Kubernetes tightly. Cloud Foundry are doing the same. Mesos, now they stopped reinforcing or doing any development on their runtime, but they are offering Kubernetes installation. So it is clear that Kubernetes is the big winner for this fight. So what is Kubernetes, you would say? So as I was describing, is generally you have different components or different containers, and you need a way to make these containers run together. What are the the possible issues that you can get of trying to run containers separately, like the connectivity of these containers? How to connect each container to the other is not straightforward, especially if you are running in distributed environment with many machines, with many cloud providers. You can end up with lots of issues with the networking. Persistent storage as well is one challenge that you can get. So sorry for the noise, guys. My kid is trying to hijack the room. So one of the advantages of Kubernetes is also it facilitates the persistent storage management for you. So if you require any persistent storage, you need someone to take care of that. And here Kubernetes comes to the help. So if you have your application, you want to run it in this kind of environment, in a large scale environment with lots of distributed resources, CPU, RAM, networking, and storage. All of that is a challenge, and Kubernetes can help you to do that. So it is called as an orchestrator for your containers. So it will do the orchestration, like it will decide where to put the containers, how to link them together, how to associate persistent storage to a particular container or to the other. If anything bad happens, it will decide how to resolve it. So here I'm putting some description of. Let me switch to the dark version. Yeah, so here I'm putting a description that I copied over from the Kubernetes documentation. So what is Kubernetes? It is a portable, extensible, and open source platform for managing containerized workloads and services. So it is open source. It is like the last time I checked, it is like the second largest repository, open source repository on GitHub. And it has a very large, rapidly growing ecosystem, because even the people that were using some other solutions, they are now accepting Kubernetes as the de facto solution for managing containers and services. So the name Kubernetes, I want just to share that it is coming from Greek, which is the helmsman or the pilot or the captain, and people tend to write Kubernetes as K8S. So don't be surprised if you see that. And it was started from Google. Based on their experience with Borg, which was the known scheduler for Google, and at some point they decided to have a change, and they started implementing this, and then they ended up open sourcing it in 2014. So it is still a pretty young project. So it is, and it is a very important tool that you need to have to sharpen your skills and knowledge. And if you are working on distributed applications, it is a must to know and master for your career. So yeah, so this is the advantage of containers, and they are all good to bundle your applications and to distribute them. All right. So the question that comes up is, when you want to manage lots of containers and you want to schedule them in a really large scale, and you want to maintain an acceptable or zero downtime, then you need someone to look after your container. So if anything bad happened to your container, it needs to get restarted or rescheduled to some new machine. If you have any issue with your connectivity, you need someone to take care of this connectivity. If you need any persistent storage for your application, you need someone to give you the persistent storage for that application, and Kubernetes is doing all of that for you. If you set up a Kubernetes environment, it will do that for you. So it will give you more resiliency for your application, because in any time your application fails, it will try to get a solution for it if possible, for sure. There are many other advantages. You can basically go, like, the best place to see the descriptions and the advantages of Kubernetes is to go to Kubernetes website and see the documentation there. There are lots of nice documentations, lots of training examples. It is a very active community behind this project. So some of the advantages of Kubernetes are the service discovery and load balancing. So if you work with web services, you kind of know the challenge of discovering services, and Kubernetes allows that in a very straightforward way, using DNS names that is very unique for Kubernetes. And also, if you want to scale up your application. Scaling up an application means, like, you have one instance of your application and you have lots of traffic coming in. So probably you decide to put another instance in to handle this load. So automatically Kubernetes allows you to have a service in front of your application, and this service will do the load balancing between the instances that you have. You can scale up to any number of instances, and still Kubernetes will do the load balancing between your instances. The storage orchestration, which is a very important feature in Kubernetes. So if you are working with a file system or a block storage that you require for your workload, for example, if you are running, let's say, a database, if you are a database provider, you definitely need some block storage in order to write the final data. And in order to do that, there are ways in Kubernetes to request some amount of storage, and it will be attached to the machine that will contain the container, and it will be mounted to the right location inside your container. And if anything bad happens to your container, this storage is somehow separate. It has a separate lifestyle or life cycle. So if your container fails, the storage will remain without any issues. And if you create a new instance of your container, it will still use the latest version of your data. So somehow you are not losing any data. All of that is automatically scheduled and orchestrated by Kubernetes. Also automated rollouts and rollbacks. So you can deploy a new version of your application. Imagine you are implementing a V0 of your application. You deployed it and customers start using it, and you want to deploy a new version. You don't like to interrupt the workloads of your customers, but you want to start the second version. Then at some point you decide to take off the previous version and kind of promote the new version to accept all the workloads. So this can be automated with Kubernetes as well in a very straightforward manner. The automated bin packing. So deciding where to run containers can become really difficult if you have thousands of containers, and if you have also thousands of machines where you want to put your containers in. So this is called bin packing, where you try to fit in a number of containers to some resources that you have. So Kubernetes allows automatically to do the bin packing for you and the scheduling part. self-healing, which is what I described previously by if anything bad happens to your container or if your containers fail, the runtime or Kubernetes will replace this container. So it will take it off and create a new one and try to resolve the issue that happened if possible. There are other features like secrets. If you want to save your secrets in in a secure way, then Kubernetes allows that as well. Any question related to this introduction to Kubernetes? Let me take a look at the chat. So if anybody has a question there, okay. So no questions so far. Okay. Okay. So then I will move on to the main concepts. But before doing that, I will jump to show how Kubernetes do all of these nice things. So when you set up a Kubernetes environment, the setup consists of putting together these components. So basically, you will have one or more machines that will work as your nodes, and they will handle the workload. So your application will be running on one of these nodes, and you have the Kubernetes engine itself, which we call the control plane. The control plane is composed of these different components. And like the first entry point to this system is the API server. So as a user or as a developer, you will be sending commands to this API server saying, run my application and my service and this persistent storage, and Kubernetes will try to figure out how to do it using a component called the scheduler, which knows how many nodes the cluster have and how many resources in each node, and how it can. This is like the component responsible for the bean packing or the scheduling. So it will decide where to place every component of your application. Then we have etcd. Etcd is a key value store. So this contains the metadata of your environment. So if anything bad happens, it should not happen to etcd because it should be the source of truth. If anything fails and restarts again, it will look at etcd in order to understand what's going on, where are the nodes, where are the components, where are the pods, and so on and so forth. So everything is safe. This is like the database of Kubernetes. Then you have a kube controller manager. This controller manager has different controllers that are continuously looking at the state of other components and managing them. So they can decide to take on or off some components based on the configuration that you have. Also, there is the controller manager, cloud controller manager. So if you are running your Kubernetes environment on some provider, let's say AWS, Google, or Microsoft Azure, then you need some specific component to understand or to do the mapping with these cloud provider components. Let's say you want to add a new node. Then this is the cloud controller manager that will set up this new node. If you need to add a load balancer generally it is a physical component. So you need someone to create an instance of this load balancer. So this is the cloud controller manager that will send the right request to the cloud provider in order to do that. So this kind of this link has a very good description of each component. You can look at that, and there are more. And one important part that it is not covered, but because it is not part of the system itself, but it is a way for you to communicate with this environment. It is called kubectl, which is the kube control or kube command line. It is not. I don't think that it is described here at all. But it is the CLI that you need to install in order to communicate with your with your cluster. Any questions so far? Does everybody understand how Kubernetes works. Like this is the control plane, and on the right side here we see how the nodes are set up. It's pretty straightforward. So they have one component called kubelet, which is responsible of starting the containers, stopping the container, mounting, executing the right commands to make a container run. This is how I would specify that. And the kube proxy, that is a component that is running on each node, and it is basically responsible for the networking part, how to connect and modify the networking setup for each node in order to make the containers talk to each other and how they are exposed. All right, so if there are no questions, I will jump back and start seeing these basic components. So here I took the description of these components also from the documentation of Kubernetes, because I couldn't do better than their description. So if you go to the documentation and see the Kubernetes objects, you will see the description of each element, and for each element as well, you can see some examples. So I just for the purpose of illustration, I picked up few items, but this is not the restrictive list. It is so far from being that. So I took the concepts that I will use in the illustration. But if you guys have any questions related to any other component, how it is being used, I can try to answer your question if I have the answer, or I can try to dig it up and find the right answer to you. So one of the main components or concepts that are being used by Kubernetes is the pod. So pod is basically the basic execution unit for Kubernetes. So for Docker, for example, we run containers. So you can run a container. For Kubernetes, you cannot run just a simple container as that. You need to have a pod. So a pod is the unit of execution, and it can be as simple as a container. So, but it can have more containers. So basically, a pod can encapsulate the application container or more, one or zero or more storage resources. You can attach storage to the pod, a network identity. And like the containers inside the pod, they can use localhost to communicate with each other. But generally, this is like one of the best practices that is encouraged, is to use one container per pod if you don't have any reason to do more. In some cases, you require to have a sidecar or another second or third container to monitor your system or something like that. But if you don't have a need or a compelling reason to do that, just keep it one container per pod, and this will make your life easier. All right. So each pod is assigned a unique IP, and that is really seen only in the. It is very like internal IP in the cluster, and the containers inside this pod, they all share the same network namespace. Yep. Okay. Same thing for the storage. You can attach storage to a pod. So you can, if your pod is a database, for example, you can you can attach a block device and use it for storing your data. You can attach a file system. You can mount a file system actually, and use it in your pod. And the different containers in the pod, they can also use the same they have the same access to the storage. Yeah, so the storage part is a whole kind of different domain. I will not go into the details of the persistent storage here, but if you guys have any questions, I have some good experience with that. I worked a lot with it, so I can help you out if you have any problems with that. So how Kubernetes works then is, so you have a kube CLI or kube CTL, which is your command line to send the commands to the API server. and you will be basically sending some orders to Kubernetes, and Kubernetes will try to execute these orders. So it is somehow you give it a state. This is my desired state, and Kubernetes will try to do some manipulations in order to go from an initial state to this desired state. For example, if I want to create a job, here I could have created something, a deployment or a daemon set. So these are concepts related to Kubernetes that create a pod. So I can create directly a pod by itself, and I can create a pod encapsulated in a higher level component like a deployment. So a deployment basically is some kind of a controller on a pod. So it will create the pod, and also it will continue to monitor it in order to maintain its state. So for example, I can create one deployment saying that I need one instance of this pod to be running at any given time. So the deployment will set up a controller to continuously monitor and say if anything bad happens, it will restart it to put it back to the number or to the desired number of instances. And generally, how these things are described, they are using YAML files. And a YAML file can look like the following one. So you start by specifying the API version. And since Kubernetes is evolving, you can use different API versions in the same application. For example, this one is specific for batch jobs. And you specify after that the kind that you want to use. For example, you can use a job, you can use a deployment. Like you will see that deployments are really like one of the most used components of Kubernetes is the deployment. Then you give it a name.
Est-ce que j'ai une question? Quelle est la différence entre le déploiement de type kind, déploiement création d'un pod de type job, création de pod de type déploiement?
So deployment and job are completely two different concepts in Kubernetes. So a deployment is a kind of a controller that will. Excuse me, can you put yourself on mute temporarily? So there is a lot of background noise. Sorry. So a deployment is kind of a controller that will create your pod and make sure that that the pod will respect the specification that you have. For example, you can say that my pod needs to run at one instance or one replica at any given time with this particular kind of resources and this particular configuration. So at any given time, the deployment will be monitoring this pod and doing like correcting the behavior to reach the desired behavior. A job is a different thing. If you want to run something to completion, for example, you want to run your pod until it succeeds, let's say 10 times or 1 time or 100 times. You can write a job and specify that I need to run this pod until it succeeds at least 1 time, because it might fail many times. You can specify what to do when the container fails, when the pod fails, and it will try to continuously, it will try to execute it. And when it succeeds, it will check, did I reach the completion value of this job? If I did, then I will mark my job as completed, and I will kind of mark my pods as completed, but they are not using any resources because they are stopped. In the other side, in the deployment side, the container will continue run. It will continually run. It will not be marked as completed. A job also, you can specify if you want to run parallel instances of your container. Yes, Safwan, I will get back to your your question in a second. So for jobs, you can specify how many parallel instances of your pod you want to run, how many failures you can tolerate, and how how many times you wanted to succeed before saying that it was successful, or how many times it failed in order to declare it a failed job. So they have two different functionalities basically. Does this answer your question, Ahmed?
Yeah, it's clear. Thank you very much.
All right. So Safwan asked the question on the chat, why we need pods in Kubernetes, why we can't work with containers. So as I was saying, like the pod so the containers themselves, there are some runtime units. So you want to execute a container. But with Kubernetes, it manages more than that. It manages more context than the runtime itself, because it handles the networking for you. It handles the persistent storage for you, and you can run many containers together within the same pod. So this is some extra to the container. So you can run one container as one pod, which will work fine. But definitely you need some networking aspects to it, and if you require also some persistent storage, then you cannot do that in the container itself. Especially like even in Docker environment, if you want to run a Docker container by itself, there is a way to add persistent storage, and there is a way to manage the networking, but it is not really practical in a large-scale environment. You want to have this context embedded with the container. So each container has its own configuration and its own persistent storage and its own networking setup. So this is why we use pods instead of just mere containers. Does this answer the question, Safwan?
Yes, thank you.
All right. Okay, so any other questions? All right, then I will jump to the next thing. So after, like, we will see how to use deployments in this case, and a deployment, as I was saying, it can be related to one or more pods. Then after deploying your workload, then there is an aspect of exposing it to the world. So you want this workload to be exposed and be like discoverable, and people should be able to use it in a steady way, like in a resilient or reliable way. So how to do that? Kubernetes offers a mechanism called services. And this is basically adding a DNS name for your container, for your workload, and allowing people to use this DNS name to talk to the pod instead of using any ephemeral IP address. So when I say ephemeral IP address, because when you create a pod, it will get an IP address to itself. But if the pod gets restarted, which happens like all of the time in microservices, if your container fails, the pod will get recreated and it will get a new IP address. So it is not really that useful or practical to use the IP address of the pod in order to talk to this particular workload, because the IP address will change every time and you will end up trying to use a different IP address, which is not really useful. So they come up with the service concept, which is creating a service that has this static or fixed IP address or endpoint or DNS name, and it will always bind to the different pods that you have running, and you can make the link between the service and the running pod using what we call labels. So, for example, you want to run your Hello World application. You started, it will get some specific IP address, and you create a service, and you say that this service should map to my Hello World application. So what you say that I need to label my application with the label app, my app. And then in the service side, you say that any pod that will have this label, it will be exposed using this service. So this is how Kubernetes exposes services. So if you see here, So if I need this to expose a real application, I need to tag it or label it with the same label that is used in the selector of the service. So after that, in my service, you see also that I'm using a different API version. The kind is called service here. I give it a name that will be used as the DNS name of my service. So internally, anybody can talk to my workload using this name. So it's going to be my service and the port number, for example, port 80 or any port that I specify. Then you can specify what is the port being exposed by this application, and how to, if you want to change it, you can use the same port for sure, but generally people choose a different port for the service if the port is a common used one. Like port 80 is generally overloaded, so people end up using a different target port that will be exposed in the host. So when you try to use this service, you will use this port with the name with this DNS name. Any questions? So as I was saying, like services are the way to expose your application to the world, and there are different types of services, and some of them are useful for you in a particular context, and they are not useful in others. So for example, the cluster IP type of service, this is the default type of service, which will give your service an IP address that is visible only inside your cluster, so you cannot use it outside. So if you try to use that service, you will not be able to do it from outside the cluster. There is the node port, which is also another way, but this allows you to expose the service outside the cluster. So each node that you will have, it will open up the port that you will get in the node port, and it is basically a very high port. I think it is between 32,000 and 33,000 something port that will be associated to your service. And this is useful, for example, in local environment. If you are using Minikube, for example, you will be using that really often. The load balancer is basically a way to use a physical load balancer if you are using a cloud provider. You need to remember this. Load balancer is not useful if you are in a local environment, because it is trying to get a physical load balancer and expose it to and use it in your environment. So if you are not using a cloud provider like AWS or Google or Microsoft, please don't try to use the load balancer. It will remain in a pending state, and you will not get any external IP address, unlike the cloud provider where they will associate a load balancer for you to be used to expose your service. The external name, I didn't use it that often, but it seems to be a new feature, or I don't know when this feature was added. But if you are using a service that is outside of your cluster, but still you want to have a fixed name or fixed CNAME for that service, you can use this type of service. The final concept that I would present, and I will stop here. There are many other concepts, but just for the sake of time, I will stop with the ingress. That is very useful feature in Kubernetes that allows you to expose your service or your services if they are using HTTP or HTTPS routes outside of your cluster. And in order to use that, you need to have some specific controller that will basically detect your incoming queries and routing them to the right service. For example, here as an example, you see that I'm creating a test ingress, And this ingress is using Nginx, which can be used as a web server or a proxy as well. And in this case, it is used as an ingress controller. And any call that will arrive on this particular path on your endpoint, so it will forward it to the service that is called test on the port 80. So it is a way to so one of the advantages of using ingress controllers is that you can collect many services together and have to pay for only one endpoint, because the ingress is very useful if you are in a cloud provider where you need to pay for any endpoint that you will expose outside of your cluster. So you want to reduce this number of endpoints. So ingress allows you to do that, and we will see in a second how we will use ingress in our example. Any questions? Does it seem somehow complicated?
Just for the node port, the cluster IP.
Mm-hmm.
Can you explain or elaborate what does mean? Where is that? Service only reachable from default service type.
Okay, so this is the default service type. So if you don't specify any service type, you will end up with a cluster IP service. And I'm saying here that this value makes the service only reachable from within the cluster. So the IP address that you will get is not visible from outside. Let's imagine that you have a cluster composed of 3 nodes. All right. Mm-hmm. And you created a service that is a cluster IP service. Its type is cluster IP, and you go from a fourth machine that is not part of the cluster. If you try to access to the IP address for this service, you will not be able to do that.
Okay. So because I tried to access for a service from the cluster, but it doesn't allow me. Always the request is not reachable. I don't.
So if you are using the right IP address, or you can so basically with services, if you are from within the cluster or from a pod inside the cluster, you can use exactly the name of the service as your target. For example, here, instead of using an IP address, I can use HTTP // my service, and I can use the port for that service directly. And if you are using the IP address and the right port, and if your application is opening that port, because you need to make sure that the application is also open to that connection, then you should be able to reach it. Otherwise, there is something wrong with your configuration.
Okay, because I make 2 different configuration. The first one, it's a cluster type cluster IP. The second one is a node IP. The node port it's run correctly, but the cluster IP doesn't.
Yeah, because so if you are trying to access the service from the outside, the cluster IP will not. But if you are inside, it should work with the right IP and the right port. It should work.
I try inside the cluster, but
yeah, you might have some wrong configuration that you tried, because this is the way it is designed, and this is the way it works.
Okay, thank you.
Yeah, but generally, if you want to expose it outside, try to use either the node port or use an ingress if you are using that locally. The cluster IP is just for in-cluster communication. For example, in our example, I will show that my product service will use the rating service, and it will use the default thing. I will not specify any type, so it will be the cluster IP service, and it will use the rating service in there.
Okay, thank you.
All right. Any other questions? Okay. If not, I will jump into the.
Just can we active ingress service with the node port service?
You can, yes, you can, yeah, you can do that.
Is the best practice or not?
So generally, so I would say there is no kind of restriction from doing that. There is no harm from doing that, from doing ingress with any kind of services. The only thing that I don't see like really makes a lot of sense is to use ingress with the load balancer, because both of them have the same role. Ingress is being used to reduce the cost, but if you use it with a load balancer, then you are paying twice the cost. So this is the only restriction that I see. But other than that, I don't see any issue with using both together.
Mohamed, pour le load balancer, si tu t'appuies sur un fournisseur cloud, tu n'as pas besoin de load balancer, c'est ça? Ce que tu viens de dire tout à l'heure.
So it's either, so when you use the load balancer, you can see it as you are paying money for an extra service, because they will set up a physical load balancer for your service. If you are using ingress, you will be also paying for a load balancer for the ingress to work. So
non, je parle pas de ingress. Lorsque tu as parlé tout à l'heure de load balancer, tu as dit en fait, il faut pas avoir un load balancer et lorsqu'on va déployer dans un cloud, c'est ça? Parce que le cloud fournisseur cloud lui-même, il peut te fournir un load balancer.
No, it's exactly the opposite. Like a load balancer is not useful in a local environment. You should not use a load balancer in a local environment, because you don't have the physical load balancer. But if you are in a cloud provider, you can use the load balancer and it will associate the physical device for your service.
Ah d'accord, oui, d'accord. Donc si tu utilises un provider, tu dois lui associer un load balancer que tu peux prendre.
It's not you must, but you can.
Ouais, d'accord.
You can use a load balancer to expose.
Et dans un environnement local, tu n'as pas besoin parce que tu.
You cannot. It doesn't make any sense. It will not give you a real load balancer, because the objective of the load balancer is to have an external endpoint. So if you do, for example, if I do, I don't know if I have any configuration. I don't have a Kubernetes environment probably up and running. Let me see. Yeah, if you see here, I tried to get the service. For each service, you have some external IP field here. And the objective of using the load balancer is to get an external IP. So if you don't get the external IP, then it is another service, another normal service. And you cannot get an external IP unless you are using a cloud provider.
D'accord. Mais le load balancer, c'est pas seulement pour avoir un external IP, il a d'autres rôles. Mais c'est vrai, c'est-à-dire il joue le rôle d'un external IP.
Yes, so the main usage of the load balancer is to in the Kubernetes service type. It's not in general. I'm not talking about the general load balancer term. This is like the service type of load balancer in Kubernetes. It is mainly used to like the main difference between a normal service and a load balancer service, that it will give you an external IP. This is the main difference.
But does it play the normal role of a load balancer? I mean,
all the services in Kubernetes play the role of load balancing. Any service like the cluster IP, the node port, all of them, they play the normal role of load balancing, which is sending, like doing, for example, a round robin between the different instances of your application. All of them do that. But the main difference of the load balancer type is that it gets you also an external IP.
Okay.
All right. So so here, in order to make the illustration using Kubernetes, there are different ways of doing it. You can set up your own cluster. You can use a cloud provider, and they will give you a nice Kubernetes environment. Or you can, if you want to try things in your machine, you can use Minikube. I put here the link of installing Minikube. And you can try that by yourself and do the installation. It's pretty straightforward. Probably you need some good resources in your machine. Personally, so in this course and in the next session as well, or in the next following 2 sessions, all what I need is 4 gigs of memory and 4 CPUs for Minikube. So this will be used by my system setup, like the Kubernetes environment setup, and all the containers that I will be doing. So I will not consume more than that. So did anybody have any issues with installing Minikube? All right, so let me start.
J'ai installé kubeadmin. Est-ce qu'il y a une différence par rapport à Minikube?
So Minikube is very simple. It is starting one virtual machine that contains all the components of Kubernetes in your system. So it is only one contained component that contains everything. But kubeadm is a tool to do more. You can install a distributed system. Like if you have many machines, you can set up the master in one of them using kubeadm. You can use the other as a node to join the master using kubeadm as well. So kubeadm is a tool to make the installation, while Minikube is a one node instance that contains all the components of Kubernetes in one single virtual machine.
Okay.
So I can say that kubeadm is used for more advanced usage and more scalable ways. Minikube is only used for testing and learning new things. If you want to test something really fast in your environment, just use Minikube. It will allow you in a minute. I will show you how fast it's going to set up the environment for me. So let me.
Est-ce que si j'ai besoin de tester quelque chose dans l'environnement Kubernetes, si je le teste dans le Minikube, ça va fonctionner pour les autres cas des outils, par exemple kubeadmin ou même dans le Kubernetes dans un cloud provider?
Yes, it should. Like indeed, like Minikube doesn't have like 100% of the features that Kubernetes environment has, but it has most of them. So if you want to try any feature, it should work. If it works in Minikube, it should work with, I would say, it can work out of the box in any other Kubernetes environment, or it might require just a small change, if any. But generally, whatever works in your Minikube will work in any Kubernetes environment.
Par exemple, les cas pour le déploiement des applications stateful set, comme les cas de Spark, Hadoop, est-ce que Minikube, ça peut fonctionner?
You can set up a stateful set in Minikube, but it has a limitation in terms of the persistent storage. It supports localhost storage. It doesn't have support for external, let's say, I don't know, EBS or EFS or any other type of storage, but it has host path, it is called. It supports host path storage, and you can do that if you have enough resources in your machine. Then you can run any workload to do that.
Okay, merci.
So yeah, so after installing Minikube, like the fact of creating a Kubernetes cluster is really. Let me stop the previous environment. We don't need the compose anymore. So I will go to KS now. So like how to start a Kubernetes cluster using Minikube is basically saying Minikube start, and it will default to some values. But if you want to specify how much memory and CPU, there are lots of flags that you can use. But you can say Minikube start, and it will start setting up your environment. So let's do that. So it should get started. So it will use the latest version that you have in your system, and it will install one node Kubernetes, and you can test almost all the features of Kubernetes. I say almost because some of them are not 100% supported. Any other questions while waiting for Minikube to be ready for us? All right. So in the same repo here, I also put some the equivalent required YAML files in order to deploy our application. The same distributed application that we had here. So this one should go away. Okay, it's not running anymore. So if you see, you see that it took just a few seconds to start my my Kubernetes environment, and now if I do kubectl, it will also automatically configure your kubectl if you have it installed already. In Kubernetes, you will start talking to the API, saying like, give me all the pods, give me, for example, the namespaces that you have. So you see that I have some default namespace that I will be using. You can see if there are any services by kubectl get and the name of the object. Then, in order to create things, you need to do a kubectl apply or create, and you can specify the file that you have. So let me jump back to the configuration. So you can test with a simple use case to see if this will run or not. So this is creating a deployment based on this image. It is like a very easy thing that you can do. Let me do that. So what is this doing? So it is basically getting a Docker container, a Docker image called from this location, and creating a deployment called hello minikube. So this is what it is doing exactly. So if I do this, you see that it downloaded the image and it created this thing. So if I do kubectl get pods now, I need to see that this pod is being created out of the description. And if I do kubectl get deployment, you will see that I have the controller. So this controller is called hello minikube. And it is saying that it needs one pod to be ready, but now it has only 0. So it will continue to try to reach this this number to have one pod running. Now it is saying that it has one pod running. So if I do kubectl get pod, you will see that it is up and running, and we can for example see. I think it's logs. We can see the logs for this pod. For example, it is writing like starting Nginx. So this is what it did. So yeah, so you can see that this pod is running, and we can also delete things. So I can. So let's see. So if I do get pods and I do a delete for this pod, so since the deployment is managing this pod, it needs to get recreated. So if I do this and I do a get pod again, you see that the one that I deleted, which ends with RV7, is terminated. But at the same time, the controller, which is the deployment, created a new one, because we are saying for the deployment that at any given time, you need to have one instance running. So as many times I delete this pod, it will get recreated. And I can edit my deployment. So if I do kubectl get deployment, so I can do a kubectl edit the deployment, and I can do this, and it will open up the description of my deployment, and I can modify the number of replicas. Let's say I want to run 3 replicas of this thing. So if I do that,
Mohamed, le déploiement, tu l'as récupéré de l'image que tu as chargée, c'est ça?
Yes. So when I did the create deployment here, so here I did create a deployment, and this is the name of the deployment, and this is the image.
Et dans l'image, tu as le déploiement.
Yes. No. So the deployment here, it will create some default behavior. Like it will create a deployment out of the parameters that I will be passing. So these are the only things that I changed. All the other will be the default values. So for example, the number of replicas will default to 1, for example.
Ah, ça, c'était créé par défaut, c'est ça?
Yes, exactly.
Le fichier que tu es en train d'éditer, il était créé par défaut.
Yes, exactly. So if you see if I did the edit, so all of that was created for me. I didn't do anything. The only thing that I specified is the name, which is this one, and the image. All the others are default. So now I can. You saw that I have 3 instances now, and I can scale it down to 0, for example. And you will see that all of them are terminating. Deployment, and I will delete the deployment here because I don't need it anymore, and I will not have anything. So these 3 pods are terminating, so they will take some time and then just go away. Any questions so far? If not, I will jump back to the...
Le fichier de déploiement, généralement, en fait, comme tu l'as montré, on ne le crée pas from scratch. C'est l'outil qui te le crée pour toi et après tu l'édites.
No, generally you create it.
Et là, dans l'exemple que tu m'as montré, ça a été créé par défaut.
So these are like for simple use cases where you want to test something, you can make the tool create it for you. But in general, you will need to create these files with the right description of your deployment.
From scratch?
Yeah, generally from scratch, but most of the time people end up copying from one thing.
Okay.
Yeah, from one.
But there is no tool to auto-generate for you.
So there are some tools. For example, there is a tool to generate. If you have a Docker Compose file, there is a tool to generate the
that translate from Docker Compose to...
Yes, okay. But I don't remember seeing a tool that will generate everything for you that is open source. I saw, I don't know, in Apple, for example, I saw a tool that they have where you start filling some fields, and then they will generate all the YAML files for you. So I guess that other companies, they have their own tools, but generally this is how you do it. And also, if you are using, let's say, an open source solution, you will find the deployment files in their environment. So for example, if you want to deploy MongoDB, you can find a MongoDB stateful set or deployment or a pod or something like that. So you can just take it, adapt it to your needs, and it will just work. All right, so let's try to deploy this same application using Kubernetes. So basically, I shared with you the configuration. So these are the files needed. So for each component, we have 3 components basically. So we need to have a deployment and a service for each one to be used. And particularly for the front end, we need also to use ingress in order to be able to see it externally, because we are supposed to be out of the of this cluster, so we need an ingress to consume it. There are other ways to do it, but I wanted to use the ingress just to show you the mechanism. All right, so let me open these documents. I will start with deploying the ratings. Okay, so the ratings deployment. So it's pretty straightforward. So it is the specifying the version, API version, and the kind as a deployment. Then specifying some labels that I will be using in my application. Then a name for my deployment. And after that, there is a specification that contains the template of my container. And the most important part is this containers, where I can put 1 or more containers. In this example, it is only 1 container. And you can specify the name of the image with the tags and everything. You can specify the port that you need to expose. So this is very important to be able to consume your service. So you need to expose a port here. And also there are some things that you can specify. These are not required. So they can be defaulted to some values. But for me, since I'm using Minikube, I'm trying kind of to minimize the amount of the resources. And since I know that this is a Go application, I know that it doesn't require a lot of CPU and memory. So I just limit it to a very, very small amount of resources. So so let me go to Horizon.
Là, tu spécifies pas le type de conteneur. Est-ce que c'est un, comme on l'a vu tout à l'heure, est-ce que c'est par rapport au port qu'il expose? Est-ce que c'est interne ou pas?
Yeah, I didn't reach that step yet. So here I'm just deploying the thing. Then I will need to expose it. So for each component, I need to deploy it and I need to expose it. I can have them in the same file for sure, but generally it is preferred to separate these things in different files. So you will have the deployment file or the stateful set of the job, and you will have the service that is exposing this workload. So until now, so if I do a kubectl get pods, I don't have anything. kubectl get services. I have only the default Kubernetes service. So let's do kubectl apply. I will give it the file that is ratings deployment. So if I do kubectl get pods, now my pod is running. So now how to access to my pod? So there are ways to do port forwarding, but this is not the best way to access the service. So the next thing is I need to have a service for this pod. If I do a describe for this pod, and I put the name, it will show me. I think, oh, actually, if I do a get. So if I do a get on the pod and I specify this flag, which is wide, it will give me a longer description of the pod that contains the IP address. And this IP address will change for each run. So if I delete this one, it will. So this is a 0.4 pod. So if I do now, so if I do a get again. It will have, oh, actually, for this particular case, it got the same IP address, but generally it is not, you can end up with different addresses. So for example, if I scale it up, it will have a different IP address. If I scale it down, it will change. So it is not useful to use this IP address to communicate with the service. So instead of that, we need to use a service. So, and this is where I create a service. So here I'm saying that I need to create a rating service, and this rating service is exposing this port, which is 9998, and it will bind to any application that has this selector app ratings. So if I go back to my ratings deployment, you will see that I'm having this label in my application. So my application will be labeled with that. So my service will be exposing this particular application, not any other application. And this is how the services are bound to the applications. Okay, so now if I check the services, I have a service called ratings now. So from inside the cluster, this IP address is known. And also this DNS name is known. So if I am in a container inside and I want to talk to the rating service, I can call it with ratings and I can use the port 9998. So this should resolve and I should get a response. Okay, so I will use the same thing for deployment. So if you look at the deployment file, it is almost the same thing, except the image that is using this Go products instead of the ratings, and also same amount of resources, but exposing the port 9999. Okay. I will apply the deployment, product deployment. So I'm using some aliases here. So it is creating the image, and now it is running. Now I need to expose my my service. So now I will create a different service for the products, and the type here is a node port. So I'm using a node port to expose my service because my application, my front end will be running on the browser, which is something external to the Kube system, and needs some access, some specific access to this service. This is why I'm using the node port in my configuration. So I will create this node port service, and kubectl get services. So you see now the difference between the rating service and the product service, that I got an extra port, which is a high port that is 32262. This allows me to access to my to my service. So if I do if I try to access that, I will be able to access it. So there is a feature in Minikube called you can get the IP of this point. Since it is only one node, we can use that. So I can do a curl, let's say, and I need to use this port in order to be able to access to that service because the other one is not visible outside. This is also Safwan. Probably you got this issue before. If you try to use the port 9999 from the outside, you will not be able to see any output. But if you try to use this, products. So now it is getting a 404 page, which is good. It means that it is trying to access the thing. So it is recognized. So if I go and look at the code of my my product. So this is my product, and this is the web server. Just to check which endpoint I need to hit. So it is /v1/products. So if I remove the slash here, I should see some result from my from my container. So now I know that my container is accessible at this point. So at this particular address. So what I will do. So now something very specific for my Roadrunner in the configuration here. I have some specific reference to my product environment. So if I go here and see the Axios prod file, yeah. So here I was in the previous version. Minikube started with this particular IP, but now it changed the IP. So in order to get everything up and running, I need to rebuild my my container. So I need to build again, to build my yeah. So I need to build my my image again. So I did a small change in the code. I built the image. Then I will push it to Docker Hub, and after that I will be able to access my to create my my front end using that will consume the product service using this this particular IP address. Any questions so far? So this is not generally how people. Like in a real environment, you should not do a modification in the configuration for the source code, because you need to pass these configuration in the in the files, like an environment variable, for example, or a configuration map or something like that. But this is just for the illustration of this example. So I can then I can apply my my front end.
Mohamed, tu peux pas manager le. T'as pas la main sur l'attribution de l'adresse IP du tout.
There are ways to there are ways to do it. Yeah. There are ways to do it. I looked at that up yesterday, and there are ways to do it. But I didn't want just to lose so much time just in doing that, because it is a straightforward thing. So for Minikube, whenever you delete it and restart it, it will increase this IP. But there is a way to set it up to fix it. But since I don't use Minikube really often in my environments, I just didn't want to lose lots of time just to debug this particular feature. All right, so in my configuration here, so the front-end deployment is also very similar to the others, except the name of the image. And I give it a little bit more resources because I know it is in Nginx and it requires a little bit more probably. So and it is using the port 80 here. But it is a pretty simple deployment. So it is front-end deployment. So now I have my deployment up and running. So it is running, but there is no way for me to access it. So I need to create a service. So here I'm creating a normal service. You see here, I'm not creating any specific thing. So it is going to be a cluster IP because I know that that I will need to use ingress in order to have access to that. So I will just create this service, and this will be mapping the port 80 that is exposed by the container to the port 8989 in the service itself. All right. So you see that I have a front-end service here that is exposing 8989. And if you do kubectl describe on any of these services, you will see if it is mapping to the right endpoint. So here it is mapping to this pod IP on the port 80. And if you check, you will find that this is the IP of the front end pod. So you see the front end pod, it is using 06, which is the same endpoint of the service. And this is basically using the labels to make the right mapping. So now how can we access the front end of our application? This is where comes the ingress. So we need to have an ingress controller to be able to do that. But luckily, Minikube has this feature, so we can enable this ingress controller by doing this. Minikube add-ons enable ingress. I already have that in the configuration here. So after doing the deployment, you need to enable the ingress. So in a real environment, you need to have a proper ingress controller, but this Minikube comes with one that you need to enable. After that, we can create our ingress. So what is an ingress? So it is basically saying that for this host, for example, products.example, any call that is coming on this path, the slash path, just send it to front end 8989, which is the service name that we created, the service that we created here. So here you see that I have a service called front end, which is this one, which is a DNS name, and this is the port that is exposed by this service. Okay, so I will apply this configuration, and so you can see kubectl get ingress. You can see that the ingress was created for products.example. So if I try to access this right away, it will not work because I don't own this this domain. But instead, there is a small trick just to make the things work in this particular environment. So in general, if you do that in a real environment, you will get the host and you will be able to access it without any change. But since I am in a local machine and I don't own this domain name, I can do a small change in my hosts file just to tweak things. So I would say that this particular products.example should go to the IP of my Minikube. And doing that, so if I go here, all right, so if I hit this, so I should be in my application again. So it is using my service, and if I refresh, I will see the things moving there, and I can see the log of my products, for example, that is responding or not. So every time I refresh here, I should see. All right, so every time I refresh, I should see the numbers here changing. For example, this one, let's select that one. If I do this one, you see that the execution is happening correctly. So the call going from my browser to my container, and from my container to the product service, to the rating service, and going back with the right results. Any questions so far?
J'ai pas compris la dernière partie où tu as fait par rapport au ETC slash.
All right. So basically, in order to be able to access my service, I needed to have a host, right? In order to use it, I can directly access the service using the IP, but I wanted to use a real name, like a host, a DNS name. Here you see I'm accessing as products.example, right? But this is a domain name that I don't own. So just to make my machine thinks that I have this domain and I own it, I needed to make a small change to the hosts, saying that any call that you will receive on products.example, send it to Minikube.
Ah, ok, c'est juste un DNS local, une sorte de DNS local.
Exactly, it is just tweaking my hosts thing. But in general, if you are running in a real environment, you don't need that, because you will have the domain name that you own, and you have everything set up correctly. This is only for the purpose of the demo, for sure. And generally, you don't really need to modify your hosts or your Etsy hosts in order to do that. Any other questions? So I think we are almost done. So I have the all the configuration shared in the GitHub repo, and you could basically repeat the same thing using just kubectl apply -f with giving the dot in the same folder, so it will apply all the configuration. You don't need to do them one by one, and it will just execute the thing and do it for you. And if you are trying to do the same thing, make sure that you don't forget the Etsy host thing, and to attribute the Minikube IP to that host, so your system will forward the calls to that particular.
Mohamed, quelle est la différence entre apply ou create?
So the difference is, so the new way to do things. So in the beginning, Kubernetes started with only create, and it ended up doing adding the apply. So apply will try to even reconfigure something. Create is only one thing that will create something. If it exists already, it will fail. It will tell you that this thing exists. Apply will try to see if this element exists, and if there are any changes between the current version that is running and the previous version. If there are changes and you can change them, it will apply them. If it cannot, it will tell you that this is an immutable field and you cannot change it. You see the difference? So it is basically one. You can see it in the HTTP world as the HTTP post in the put, where the post allows you to create things, but the put allows you to create and update as well. So create allows you only to create things based on files or any other configuration. Apply allows you to create and also modify.
Okay, merci.
Any other questions? All right, so guys, feel free to take the quiz. It's a pretty straightforward quiz, and in the next session, hopefully, I will see all of you in the next session, and we will do some very exciting stuff related to CI/CD, or continuous integration and continuous deployment. I will use Concourse as a use case, which is a pretty fancy CI/CD pipeline tool. So please try to join. Also, I wanted to ask people about their schedule. So the next week we will not have any session because it's Eid, and like the session after that is going to be the next the week after next. So if you guys, if you prefer to remain in the same day, same time, then this works fine with me. If you prefer to have it in a prior time, also, because I know after Eid, people's schedules start to change a little bit, and people prefer to do something earlier than 9 p.m. So if you prefer that, please let me know, and we can schedule the next live at 6 p.m. or so. Any proposals? Any comments? You can use the chat as well to give your preference if you want. And also, if you have any final questions, I'm really happy. So I will just go ahead and stop the recording now.
Mohamed, vous pouvez me faire entrer dans le groupe